Alright guys, here we are. I want to show you one of the finest trailers we've ever had in this shop. It is a fully aluminum trailer built by a company called Intech. This trailer was ordered custom by the customer. It is roughly averages about $20,000. Has a beautiful white interior, 12 volt LED lighting. The fit and finish on this thing is fantastic. I could strongly recommend to anybody looking to buy a trailer to speak with this company. Again, it's all aluminum. It's going to hold up to the northern elements a lot better than the steel trailers that we get here out of Georgia. Again, it's screwless exterior, very nice gray, heavy duty 15,000 GVW. A pair of axles here with brakes, nice custom wheels. Again, here's the company Intech, and just heavy duty everything. These handles are heavy duty. Customer brought it to us with this finish on the floor, very nice epoxy type, heavy duty, skid proof finish. We spilled a little resin, a little ISO on it, but it's cleaned up very well. And we will just continue this tour in just a second. All right, so here's a shot from the rear coming up into this trailer. Again, you'll see the wheel wells are aluminum. Everything on this is aluminum frame, whole 9 yards. Again, beautiful white interior. This unit he ordered with AC and heat. We have configured this to work offshore power as well as when his generator is running for those hot summer afternoons when you want a little place to escape. Catch a little cool air. But we're going to go through this rig pretty in depth because of this build. It's very custom, and I just want you guys to understand everything that's gone on in here. We're going to start out up here. This is your control room, I guess you can call it, your equipment room, your power source room. We've got everything in here that makes noise behind a door. So the back end of this trailer is much quieter. This came to us with this 120 volt RV style breaker fuse panel that actually converts also 12 volt power to run the lighting. But what we did is we put in a manual selector switch here that allows you to either pick between shore power and or generator power. If you decide to do that, that feeds our breaker box that we put in that powers this equipment. So starting over here on the right side of the trailer, this is a Porter cable, 1.6 horsepower, 5.3 CFM compressor. The only thing this compressor runs on this trailer is the gun. Our system, the CDS proportioning system, does not have drum pumps, and there's a long technical explanation of why that's better than stick pumps. If you're more than happy to send you our white paper technical bulletin on our reasoning for doing that. So that's all this runs. This runs into a 20 CFM Scholl's refrigerated air dryer. It's actually manufactured by a company called Beko, B-E-K-O. We've put it on a very nice stand to get it up off the floor. This has multiple outputs on it if you decide to run some additional air sources. You're going to hear air every now and then. This automatically spits the compressed water, condensed water, out the bottom of the trailer. And you'll see down there on the floor, you might be able to see that little hose going out through the floor. To power this system, we have a 30 kW Kubota diesel generator. The customer requested us not to do the exhaust because he's going to do something a little more custom. But this is a great running generator. We'll fire this thing up in a minute. Starts within the first 1 second. It's a great little generator. We have a 55 gallon diesel transfer tank here that has the draw from the bottom and returns any unused fuel back to the top of the tank. easily accessible from the door. Pull up to any filling station and fill it up right there. So this is our mechanical room. We're going to fire this stuff up, and we'll get you familiar with how this stuff operates. So the way this system runs, like we stated earlier, we do not have a drum pump package that picks up material out of the drum and then sends it to the machine. Basically, our proportioning pumps are divorced. There's one on each wall of this trailer, and they are individually controlled, so we can manipulate the flow and or the count of how these pumps operate. So traditionally, you have a single motor, whether it's air, electric, or hydraulic, that is attached to a pair of pumps that are tied together. The problem lies is that the viscosity of this beam material, the resin, is triple the viscosity of the ISO at 70 degrees. The rule of thumb, and every understanding that I've had in the 25 years that I've been doing this, is every 10 degrees below 70, that B side viscosity doubles and the A side does not. So you have about a 250 centipoise material here at 70 and a 1200 centipoise material here at 70 degrees. But if this was at 60 degrees, it would be 2,000 to 2,500 centipoise. The A side does not change like that. The A side might thicken up a little bit. It might go from 250 to 300, but it doesn't double. And it only reaches a point where it gets so cold then it freezes. So we have an issue here of trying to put a heavy-duty Wendy's Frosty through a straw and putting Coca-Cola through a straw. They're both going to give you different back pressures on the system. They're both going to behave differently. You're going to use the volume differently. The drum pumps are going to pick them up differently. The blowing agent, if you're buying a B side that has 245 FA blowing agent in it, will compress at two different ratios. It'll compress one time in the drum pump, and it will compress again in the proportioning pump. So we are eliminating one entire process as well as a big compressor with the drum pump packages. So the flow process here is that these pumps pick up this material out of these drums. There is a check ball on the bottom of the pump here, and every time this pump either goes up or down, the check balls all move in the same direction. And that is very improbable for all of the check valves to move in the same direction when you throw drum pumps into the equation. So the material gets picked up and this 1-inch truck hose goes through this pump system here. It is pressurized. We use these ultrasonic flow meters that keep track of the flow going through the system. Goes into a filter, comes up over the top of the trailer, and comes into our heating system. From our heating system, it goes through this block system here where we have digital pressure gauges as well as analog pressure gauges. So you can get a quick view on what your pressures are on your A and B side and adjust those accordingly. As well, the digital pressure gauges will record in the CPU all of your pressures throughout the day. It will record temperature, it will record strokes, it will record flow using the ultrasonic flow meters. To power this system, we have a proprietary 5 horsepower hydraulic power pack, and I ran this thing up today on accident to 4,000 psi. Fortunately, we weren't pumping material yet. But this system is capable. I've run these pressure gauges about 4,000 psi. I mean, I've pretty well pegged these things. We don't recommend that. I don't know how often you'll ever use that. You will spray foam at roughly 1,000, maybe 1,200 pounds, polyureas, you'll spray anywhere from 2,000 to about 2,800 pounds. So you have plenty of pressure. We are looking at these pumps that do 3 gallons a minute is what I've seen the flow meters say. And if you multiply that by about 10 pounds per gallon times 2, you're running almost 60 pounds a minute through this machine. Of course, you're going to put a gun on the end of this hose that only allows you to run somewhere from 17 to 25 pounds a minute if you're doing traditional spraying. So this is our primary heating system. We build this unit here. They start as pure blocks of aluminum. They are gun board, and we have installed 3 A-side and 3 B-side 1250 watt rods in here. It is a very efficient heater. We have recorded delta close to 100 degrees. And one of the things I really want to bring to your attention is that I don't know any other rig in the business yet that actually has an analog temperature gauge just outside their heat block. The first time that you can actually see true temperature of material is normally at the end of the hose using the thermosensing unit that registers temperature fluid at the gun. Our rig also has that, but we like to see what the temperature of material is coming directly out of the block before it hits the spray hose. It's just good data information to have in your head and visually be able to see. Alright, here's our A-side pump. And again, the pump will pick up directly out of the drum. It will pressurize the material. It will send it through these ultrasonic flow meters, through your filter, and out to your heating system, where you can then spray nice hot material. What I want to bring to your attention here, we are the first. I have never seen this on any rig ever. I don't know of anybody doing it. My assumption is that in the near future you might see some other manufacturers adding this type of lubrication system. This is a peristaltic pump that actually picks up mineral oil or TSU oil or whatever lubrication that you're using on your A shaft, picks it up and circulates it through the cup at about 10 gallons per day. It does turn on when we turn the hydraulic power pack on, and it is a nice visual system. You can see when it's time to change your oil. Everything's accessible, and this just does a fabulous job lubricating this A-side shaft. You can see it sitting right in there. So this pair of valves here, a lot of guys call these recirculation valves. I really don't like to recirculate material. A couple reasons is that it changes the physical properties of the material. Also, if you're shooting 2-pound or closed cell that might be co-blown, has a blowing agent in it, you're cooking the blowing agent out of it, and it's kind of like shaking a bottle of Coca-Cola a dozen times and opening it and then shaking it again. You're getting rid of all the good bubbles. So your density will change, your yield will go down. What I really like to use these for is safety. So let's just say you have a clog at the end of your hose where your gun is going to be. You take the gun off, and lo and behold, you find that your gun block has a big chunk in it, and you have 2,000 pounds in your hose. How do you get rid of that pressure? The only way without the relief valves is to slowly undo some sort of a fitting somewhere down the road, either here or down at the gun. But instead, what we can do here is I can take this valve, crack it open, dump that pressure right off of there. It goes right back to the drum. Same thing with the A side. Go ahead and dump that pressure right back to the drum. And that is how that system works right there. So this being a modular system, you might have seen some of our other videos. We have just upgraded to this new console. Everything is in it. All of our relays, all of our breakers, even our transformer is up in there. I have a 120 volt 5.5 kVA transformer in there. A lot of companies use a 4.5 kVA. And what happens is when you get out to that 400-foot mark, the hose has a little bit of a hard time heating. Amperage really drops down, but the 5.5 kVA is going to give you plenty of amperage, and you may be able to run even a little more than 400 feet of hose. But it's all in there. We're going to fire up this interface here in just a few minutes. You'll be able to see how that works. So we actually manufacture our own hose here in-house. We use 3300 PSI core, a very high pressure hose. Burst pressure is about 4 times that. We do 50-foot lengths. The thermocoupler wire is built into it, as well as the airline. We use this scuff jacket that's got Velcro, where you can actually open up the Velcro if you have to do any repairs in your hose. Very tough product, a lot better than that old Chinese finger trap braided type material. Alright guys, here we go. We're going to start this thing up from scratch. I just want to give you a quick tutorial on how that's done. You can kind of see the simplicity of this. We covered earlier that he has shore power as well as generator power. We're on shore power right now, 120 volts, which runs the lights. I can run that compressor, and it runs the air conditioning. So the very first thing that we're going to do, we need to start this generator, because that's what runs the system and the lights and everything else. So we've got to switch over. It's going to get noisy. We got to make sure our compressor's on, and we'll start the generator, then we'll move to the back room. So here we go. I'm going to go ahead and switch over to the generator. Okay, we've lost our 120 power. We're going to come back here, turn on our generator. Has auto start. We have to give it just a minute. Again, the customer is going to finish this exhaust system. He's got some better ideas, I think, that he wants to try out. So he's going to do that. Here we go. We got a generator running. Got to make sure this is on. Got to turn that on. There's our compressor. Make sure our air dryer's on. Let's get out of that noisy room right there. So the first thing I want to do is we're going to go ahead and turn on the unit. You're going to see our screen come up. It's going to have a short little error code. What it's doing during that process is that it is loading all the program and the screen communication, and that'll take just a second. Now we've been spraying a little bit already today, so our pressures, you'll see them here, we're about 1400 psi. We were pumping about 125 degree material out of the block. Our digital pressure gauges up top report back to the unit. So here's the startup screen for the unit. You hit the control panel, you're going to see pump, which is this hydraulic power pack. You hit the red button, it turns green, and these are your heaters: B heater, hose heat, and A heat. So we're going to go ahead and fire up the hydraulic power pack. There we go. It's running now. We've got close to 1000 psi of pressure on it. And the first thing we want to do is hit this hose heat, and let's start getting the hose heated up. Right now it's preset at 110 degrees, so we can open another screen, change our temperature if I want to go to 125, hit enter. Same thing for the A and the B heater. It really is just that simple. Go back to home. Like I said, we've been pumping a little bit. A side's 115, B side's 115. Hose right now is at 122. I've got a total count on the B at 28 strokes. Total count on the A at 28 strokes. And we can dial that in a little bit as my guy is spraying. We have hose amperage, 43 amps. Our digital PSI, again, I showed you on another video. I might put it towards the end of this one, how the logs work, but you can data log pressure, temperature, strokes, and ultrasonic flow meters. Really pretty easy system to run. Here we are, guys. A little bit noisy. We got the generator, everything running. You can see our flow meters right now. We're not pumping, so you're not going to see any flow. There we go. We got some flow. About a 0.6 is what that should top out at. We're running a 52 tip out there, 0.6, 0.7. Lubrication system is working. Same thing over here. We're going to watch this flow. When they start squeezing the trigger again, we'll come right back to that. Trying to squeeze in all this information so you guys can see what's going on. Got about 900 pounds on our hydraulic power pack. We are at about 1,400 pounds of fluid pressure. The guys are spraying. There you go. There's your dynamic static pressure. Got about 125 degrees coming out of the block. And here's our screen. We can do a tutorial on this one later. But we've got temperature, we've got stroke use, we've got gallons per minute, we've got gallons totally used. So the A side we've used 0.61, B side 0.61. Pressures, temperature of the A, temperature of the B, hose temperature, hose amperage. I can reset any of this stuff. We can go to the logs. I can look at the levels of what's in the drums. I can look at the temperatures, A and B and hose. You can see how the heaters kick on and off. And this updates every five minutes. It keeps 5 minutes of data. And what else we got here? Pressure. You can see where the machine was off. You can see where we've adjusted some pressures. And flow rate. You can see the flow rate. We're really trying to dial those in. So right towards the end, we got really close on that.